We're going to look at our last piece on strategies, and that's going to involve estimation. So estimation is going to be really important. We're going to use rounding to do that. We're going to look at approximate calculations, and we're going to make estimates based on information. So most of the time, if you're actually doing math because you're out at the store or you're pricing out things online, you probably use a rounding strategy to do simpler math. So when we're rounding, we consider the digit that's on the right-hand side, and if it's a 5 or more, we round up, or if it's 4 or less, we round down. And so an example of doing this is if I'm looking at a grocery bill and I've stopped at the market to pick up some things that are in this table on the next slide. So cereal, milk, bread, lunch meat, and pickles. If I sat there and tried to use those exact numbers, it would take me longer than it's worth to actually figure out the cost, right? And if I round to the nearest dollar, then that's going to be way off. So I want to find a simple way to round, which would be to round to the 10-cent increment. If I round to 10 cents, I can simply add up the dollars and then add up the cents rounded, which is really nice. And I find that it's $17.30, which is just slightly over, but really close. And you could also say, well, that milk was too expensive, so I'm going to swap it out. And because we're rounding, we can easily recalculate that based on the pricing information. And so one of the key things here with rounding and estimation is we need to use compatible numbers. So I want to find numbers that are easier to work with that won't put me too far away from the correct answer. So for example, if I'm looking at 298 and I want to divide that by 14, I'm probably going to say, well, 298 is really close to 300 and 14 is really close to 15 and 300 is divisible by that. So I would get 20. It wouldn't make sense to round to 290 and 10. That wouldn't make sense. Those aren't compatible numbers. And so if I'm using compatible numbers, I can estimate all kinds of things. So if I want to look at populations, I can easily round those off. If I'm dealing with 419 million, I could say, okay, I'm going to round that to 400 million to make my math a lot easier. And so if I'm looking at the graph, I can see that 25% is roughly where the Hispanic population is. So if I'm a quarter of the population, that gives me 100 million. And so those were compatible numbers because 24.4% is really close to 25%, and 25% makes my life a lot easier. Another thing would be estimating the size of objects. So this goes back to, remember when I had the jars and you've got the jar with so many M&Ms in it, and we're asking how many M&Ms are in the jar. This is an example of us trying to kind of estimate a size and looking at that photograph and trying to say, well, how many M&Ms look like they're in that one layer? And so I'm counting 10 in that square. So I have 16 squares with about 10 in them, which is 160 candies. So that's one of those ways that we could try to kind of get to an understanding of how many M&Ms are in the jar, is by trying to divide it into little subregions and to count what's there, because the task to count every M&M in that picture is next to impossible. But if I just count one square, that is very doable.